Okay, good morning, everybody. You're very welcome to this morning's webinar on steps to define and deliver a successful automation project. For those of you who do not know me already, my name is John Walsh, and I've spent many years in automation, both as a customer and a system integrator. So you're about to push the button on a new automation project, and perhaps you're new to the world of automation. So how do you successfully deliver and define an automation project? In case you're wondering, this is not a self-portrait, but ET is here to help me set a scene. Not only is he new to the world of automation, but he's new to this world. And he has a requirement. In this case, it's breakfast. So he looks for advice. He turns to his colleague in Hollywood, Jules, who clearly states that hamburgers are the cornerstone of any nutritious breakfast. So he goes and orders a hamburger. However, to his surprise, there is no ham in hamburger. And so the argument begins. This is not what I expected. This is not what I ordered, etc. And this scenario can easily and often happen with an automation project. The main reason for this is that there's many stages to an automation project, and these are run by many different people. So detail gets lost in translation, so to speak. This cartoon, which you may see before, demonstrates what the customer asked for, what was understood, what was designed, and finally what was built. There are a number of standard industry practices designed to prevent this from happening, from the base level quote, which is almost back of an envelope, right up to full GAMP 5. GAMP, standing for Good Automated Manufacturing Practice, is usually designed for the pharmaceutical industry, but it is a sea of paperwork. And as you move from basic quote to the full GAMP 5, the cost and the effort increases. So just as important that you select the correct automation for your process, it is equally important that you select the correct level of validation for the project. For example, a quote may work when buying something like a standard off-the-shelf printer, and in that case, full GAMP 5 would be an overkill. But if you were validating a vaccine production machine, for example, GAMP 5 would be required, and the simple quote would not suffice in that case. I have identified the 6 most relevant stages or steps required for delivering and defining a successful automation project. And these are based on the needs of a typical IMR clients. So starting with the ask or the URS, which is the user requirement specification. So details for what the machine must have, such as parts per minute and the product that will be run on the machine should be added here. And an example of such a requirement may be that the machine must give audible and visual signals of an alarm. The promise for the FDS, the functional design specification. Here, the supplier will detail how each of the requirements set in the URS will be met. For instance, in response to the request in the URS for an audible and visual alarm, the FDS would detail something like the machine will have an amber, green, a red, amber, and green light with an integrated buzzer. And the FDS then will go into detail as to how these will be used. Building. This is where the system is designed, built, and commissioned. The light and buzzer, as promised, will be fitted at this stage. Internal checks are carried out in-house by the supplier or system integrator, such as IQ, which is an installation qualification, or an OQ, an operation qualification. Here, the set light is checked to see if it works as promised. Things like parts per minute and scrap rate are also checked at this stage. Next stage is the test drive, or the FAT as such, the factory acceptance test. Here, the end user will go to the factory to test and accept the equipment. Again, referred to the audible and visual signals, the end user will test these and all other functionality while at the factory. This is a very important stage, as the end user will need to accept and be confident with the equipment as built. And finally, to bring the equipment home at the SAT, or site acceptance test. This is where you plug it in at home, so to speak, and retest anything that was dismantled during transport and test what could not be tested at FAT, say integration with other equipment. And finally, run performance tests in the equipment's own production environment. All of these various steps require validation or confirmation, which is driven by one document, the promise, the FDS. And this is why this is such an important document to get right and to keep right. Now, what I mean by this is to update this as the project progresses. to capture any changes that are requested and agreed along the way. But remember that the FDS starts with the URS, and so the URS and the requirements set there in that URS will set the FDS up for success. And this must be a collaboration between the end user and the supplier. Each party must agree on the requirements, what the supplier is happy to commit to, and what the end user is happy to accept. Keep in mind the principles of SMART when setting these requirements. Be specific. Statements such as 60 parts per minute on their own are not specific. You need to consider factors such as 60 parts per minute over an hour with a maximum value for scrap. Avoid general statements such as the machine must comply with current regulations. Be specific and list that regulation, such as the Machinery Directive 2006-42 EC. Measurable. The tests you're putting in place must have values and defined pass-fail criteria, such as defined measurement of an assembly height. Be careful of subjective measurements. For instance, visual acceptance tests are a prime example of these. For instance, flash and an ultrasonic welded part. Such a test would often be worded as a 5-second view at arm's length under normal lighting. This is subjective and can lead to difference of opinion at final acceptance. So the end user and supplier must agree a test method for this and for all other requirements and capture this in the FDS. Achievable. Listing unnecessary requirements drives up costs and adds complication. Be careful of the nice to haves, such as redundancy on machines or increased throughput based on an idea it may be used in a few years' time. For processes with a large number of finished parts, look and see which products or SKUs are low volume and might not need automation. Running a large number of SKUs also drives up cost and complications in the machine, which often reduces reliability. Set realistic goals for things like scrap rate and OEE, which is overall equipment efficiency. No machine will produce 100% good product and be available 100% of the time. Set realistic goals for things like changeover. Remember, it's costly to expect something like a 5-minute changeover if the machine changeover is infrequent, or if the machine is idle between batch changes because of other production reasons. And testable. This is covered somewhat in the steps above, but it's very important that you ask yourself, how can I test every requirement listed in the FDS or URS? In particular cases where the machine is to work downstream of existing equipment, such as a high-speed packing line, where it is not possible to feed enough parts at speed to the machine during the internal and FAT testing. Some of you will have filled in a questionnaire and just some insights from that. End users made up 56% of the replies, and you can see they were spread across a number of industries. And of those end users that answered, 67% of those used system integrators to supply automation to their factories. Various questions were asked and answered on a scale of 1 to 5. First question, or one of the questions, was familiarity with the URS, which scored just a little bit above average at 3.5 out of 5. Familiarity with FAT, SAT was slightly less at 3. People realize and recognize that this process brings value to their project. However, it was interesting to see that people were slightly more familiar with setting URS than they were with the FAT and SAT, which tested the requirements set in that document. Another interesting set of answers where the end users were surveyed. The majority of people would say the projects would go over budget, over schedule, and fail to fully meet expectations. But perhaps this is easy to see when the people who are driving this data have average knowledge of URS, FAT, and SAT practices. Expectations in particular is an interesting question and answer, as expectations are often not fully communicated through the process. Recall this cartoon from earlier, but there is one piece missing. So, if a tire hanging from a tree is really what the customer wanted, then why did they ask for a 3-tiered swing? Is this why customers' expectations are not always fully delivered? Have they asked for the right thing in the first place? So, if I bring my 3 friends back from earlier into the picture, and following all of the above steps, ET could still end up eating a hamburger for breakfast. And why? Well, that's down to lack of experience. the experience to know that the advice of his friend Jules was possibly not the best advice. Coupled with the fact there's colloquial terms and jargon used by both end user and supplier. This is where IMR's automation project assistance can help. It aims to help you to get from what you explained to what you really want or need. We can do that because we are the third eye on the process without any skin in the game, so to speak. You essentially have an automation team on your project, bringing more than 150 years combined experience. And we will use industry-proven tools and practices, as I've outlined. We will sit with you at the various stages of the project, and our input can be tailored to suit your need. To give a real-world example of where this might be useful, I visited a company and they had a robotic tinting machine where an automatic and manual operation was required. The end user had requested that the machine could be operated manually and that the operators would have access to the cell. What was delivered was an option to move the robotic arm manually using the robot pendant, allowing the operator access. This somewhat satisfied the customer's request. But the solution required operators who were trained and competent in the use of the pendant, which was a small percentage of the operators. And this led to hours of downtime waiting on a trained operator or someone who had confidence to switch modes. What IMR's experience brought to that project was to ask for a mode to park the robot and to allow manual tending of the machine. Therefore, a simple button press in the machine interface would activate a mode where the robot arm would park in a position to allow operator access, reducing the skill required to switch modes and increasing the availability of the machine. We can sit with you at the various stages of your project, and our input, as I said, can be tailored to suit your need. We'll help you develop your URS, which will start with attending a kickoff meeting. Understand the problem of the statement and define the real need. Gather info required, such as parts, drawings, SKUs, etc. Collaborate on vendors on your behalf, and agree a level of validation required. Where on that scale I showed earlier do we need to be for this project? And most importantly, bring experience to the table. We can review and verify the supplier's functional design specification, review items of non-conformance, and help understand and explain the reasons for these. And there's likely good reason for this. Ensure the principles of SMART outlined above are used, and that each of the items in the FAT can be tested. Aid the collaboration between end user and supplier. You, the customer, have IMR holding your hand through the process, cutting through the jargon, allowing you to ask the questions you may be afraid to ask. Again, during the build phase, we would sit with you to aid with design review, build review, the risk to your product, what could go wrong, where might some proof of concept be required, safety risk assessment with a view to the safety required for CE marking, review the required documentation, the internal quality checks to be carried out, the manual to be supplied, the spare parts list to be supplied, and any drawings that will accompany the final machine. We'd also suggest to put a change control in place so that the URS and FTS are kept live through the project, and therefore the FAT and SAT tests are up to date. And this would ensure also that any costs and schedule changes, if any, are captured and agreed. If required, IMR can write FAT and SAT protocols or review customer supplied protocols. Again, ensuring the SMART principles are applied to the test. IMR can physically conduct the FAT and SAT and review the documentation, as I mentioned earlier, such as the manual and all other documentation to be supplied with the machine. Again, our questionnaire went out to both end users and system integrators. And of the system integrators that we that answered the questionnaire, they just a little above average, 3.5. Again, this is on a scale of 1 to 5. Said that the correct detail is detailed in the URSs. He said without a well-defined URS, FDS, FAT, and SAT structure, the likelihood of going over budget is a little over 3. But the largest effect is on schedule and failure to meet expectations. Again, remember that the customer / end user felt projects regularly fail to meet expectations. Other insights from the system integrator's view is that there was a lack of understanding and experience regarding the limitations and applications of automation robotics. and they tend to agree that their client would need additional experience in their team to successfully implement automation projects. So that's bringing us almost to an end. Again, if anybody wants to find out more, we have a web page. The link is there, and Gary will send it out to those who register for this morning's webinar. So it's a dedicated web page to the service. You can contact me directly or through that web page at robotics@imr.ie. Thank you very much.